So the end of the unit, here's what we're, last couple assignments and the final test we're gonna do of the unit. Comes down to just kind of getting the job done. We just gotta solve quadratic equations. So there's a lot of skills we practice, but this is where it all comes together. We gotta be able to solve quadratic equations. Now, a big part of that is choosing the right method. A lot of this, you already know. Like, how are you gonna solve this one and why? Let's get all phones and earbuds and all that stuff. Should all be away, please. Yes, sir. Alex, what do you think? I mean, boy, it'd be hard to do, though. To use quadratic formula, we've got to get it into, we always have to start with standard form, right? It has to be in the form. Oh, it is. You're right. No wonders. We have to start with standard form. ax squared plus bx plus c equals 0. Then I can use the quadratic formula if I want to, but that's not in that form, right? I've got this quantity that's being squared. It doesn't fit very well. I mean, I could multiply all this out and add up like terms. I could make it work, but it's a lot of hassle. What do you think? Yeah, why? There's only one x, right? If there's a single x that I can point to, I can isolate it. Right? So the method I would use here would just be to isolate the x by reversing order of operations, right? So let's practice one of those. It's been maybe a while since we've done one of those, but we did a lot of practice, so it'll come back to you. Let's rehearse the steps, though, first. What are the steps going to be to get the x by itself? What am I going to do first? Subtract the 2. Then I'm going to divide by 3, right? Because we add, subtract, we work our way up order of operations, then we multiply or divide. Good, now what? Square root. And then once I'm there, it's pretty easy. What would the last 2 steps be? Add 3 and divide by -4 and we're done, right? So let's just practice that a little bit. So we'd end up with you told me we subtract 2. So that's going to give me, what, 73? No, sorry, no, 144. I don't know what I was dividing, I guess. 144. Then we're dividing by 3, right? So then I get something squared equals, what was it again? 48. And the something squared is a -4x minus 3, but we don't even care yet, because what am I doing next? Square rooting both sides. When I square root both sides, what do I have to include? Plus or minus. Very good. Connor, you getting all this?
Yeah.
Okay. So then we get -4x minus 3 equals plus or minus the square root of 48 if we make a factor tree. Is there a perfect square factor of 48? 16 works great. 16 and 3 and 16 is 4 and 4. So we get a couple of 4s and a single 3, right? So that's plus or minus what?
4.
Good. 4 radical 3. And then we're just going to add the 3 in front of the plus or minus. We're going to add 3 to both sides to get rid of that -3. And then the last step is divide by -4, right? But remember what we did with that. When we divide both sides by -4, when we divide both sides by -4, we're going to divide them one at a time, aren't we? Right, so here I'm going to get 3 over -4. That's just -3/4. Everybody agree? Plus or minus. What about that term? Well, it's the plus or minus term, so do I ever divide by a negative? Remember our trick? No, we don't. There's no reason to, because I've already got both signs anyway. So dividing by a negative is superfluous. Doesn't do any good. So we end up with, what is 4 radical 3 over 4?
Radical 3.
Right, those cancel. So we end up with just plus or minus radical 3. So those are my solutions then.
Got it.
Right? If you can do that, that's the hardest one I could cook up for isolating x. So if you can do that one, you got all those down. What about something like this guy, a little different? Okay, so now this one, there's a little bit of, we gotta do a little work before we can even decide how to solve this one, right?
Yeah.
There's not a single x there though, agreed? We got multiple x's, so what do I gotta do first probably?
Add 2x.
Add 2x, we gotta put it into standard form. So, standard form is just gonna look like, if I add 2x to both sides, I'm gonna get 2x squared plus how many x's on the left? 4x plus 20 equals 0. Good. Okay? Good. Now, here's where we gotta be a little bit careful. We wanna make this as simple as we can, right? Is there anything I can do to both sides to make this simpler? Like, for example, if I were doing a different problem, if I were doing the problem, let's say 2 times x plus 3 squared equals 32. Thank you. What would you do next? Yeah, you would divide by 2. Okay. Dividing, I can divide both sides of an equation by a number. I can do that. If I have an equation, as long as I treat both sides equally, I could add the same number to both sides, I could subtract the same number from both sides, I could multiply both sides by the same number, or I could divide both sides by the same number, right? Here I would divide by 2 to make things easier, right? What about up here? Is there a number that would divide into all of those terms on the left side? 2, right? So if 2 divides into everything on the left side, let's divide everything by 2 to make it easier. So if I divide each side by 2, look what we're going to get. The first term is going to give me, what's 2x squared over 2? X squared, good. What's 4x over 2? What's 20 over 2? What's 0 over anything? Much better, right? Now we've got it in standard form, but we got smaller coefficients. It's easier to deal with. Okay, so what am I going to do next here? Probably the next thing we want to think about is, could I factor this easily? Can I? Are there magic numbers here? What would they have to multiply to? 10. They'd have to multiply to 10 and add to 2. Do those numbers exist?
No.
If they did, that would have been nice though, wouldn't it? Because if they did, that makes this problem really easy. So we always want to, if A is equal to 1 like that, which we have here, we always want to just try and see if we can find some magic numbers first. Because if we can, that's the easiest way to solve a quadratic trinomial, one that's got 3 terms like this, right? It's very difficult to make a mistake too, because that's one of the things. You might know the right method and even know how to do it, but you always get it right every time? I don't. I mean, you make mistakes sometimes, and the more stuff you have to do, the more opportunity there is for a mistake. Factoring is the least amount of stuff to do between the problem and the answer, and so it's the best method when we can use it. You're least likely to make an error, factoring, okay? But we can't do it that time. So unfortunately, we can't factor, we can't isolate x because I have an x squared and an x. That would be nice too, but we can't do it. So what's probably the next option? I mean, we can always use quadratic formula. Raise your hand if you like quadratic formula. I mean, some people kind of like it a little bit, that's fine. Quadratic formula, and it always works, but the problem with quadratic formula is you got to simplify those fractions and radicals. It's not horrible, but there is a chance you can make a mistake with it. You have to do some computations. What's the other one though? We haven't solved. Completing the square. Completing the square can be really easy. Is this one going to work easily for completing the square? It is. How come? What's b equal to?
2.
So completing the square always wants us to find b over 2. That's even. So b over 2 is going to be easy to calculate. 2 divided by 2 is just 1, right? So completing the square works really well here because a is equal to 1 and b is even. When that's the case, completing the square is a really good option. It's quick and it's pretty easy and it's pretty simple to do. Okay, so let's practice that. So if I'm gonna complete the square, remember, first we gotta get it into the form x squared plus bx space equals a number, right? And then we're gonna take that line and we're going to add just the right thing to both sides so that the magic numbers it factors into are that's the same number twice. So we're gonna get just one factor times itself and one factor squared. We already know what that's gonna be. What is it? 1. Because half of 2 is 1. Well, to make that happen, what do I have to add to both sides? I'm just gonna square whatever that number there is, right? And I get 1. Now let's just make sure it works. What magic numbers multiply to 1 and add to 2? 1 and 1. There's your 1 and 1, right? X plus 1 times x plus 1. X plus 1 squared. It worked. But I gotta add the same thing to both sides. So I'm gonna get negative 9 on that side. Now it's easy, right? What's the last 2 steps to do? Very simple.
Square root sides.
Square root and get the x by itself?
Oh, add, subtract 1.
Subtract 1. Right? So all I'm going to do then, last 2 steps, if I square root both sides, I get x plus 1 equals plus or minus, what's the square root of negative 9?
Negative 9 and I.
So the negative is going to become an I, right? That's good.
There you go.
And the square root of 9 is just 3, right? So I'm going to get plus or minus 3i. And then the last thing I do, I'm just going to put the, subtract 1 right in front of the plus or minus, and my answers are x equals negative 1 plus or minus 3i. That's pretty simple, right? Completing the square, when you have an even b and a equaling 1, it's pretty simple to do, okay? So what about something like that guy? What do I have to do first? Subtract 6. I got to get it in standard form. So x squared minus 9x plus 31 equals 0. Okay, so I can't isolate x, obviously. Got multiple x's. Magic numbers, that gonna work? Multiply to 31 and add to negative 9. Good luck, that's not gonna work. 31's prime, right? Completing the square?
No.
Survey says, no, it's not gonna work because I got a negative, I have an odd value of b, right? So that's gonna make that too hard. I'm gonna have to end up with having fractions that I'm squaring. We can do it, but it's a hassle. So what's left over? Quadratic formula, right? So now all I do is just plug into the quadratic formula. So negative b plus or minus square root b squared minus 4ac over 2a, what's that give us? What's negative b?
9.
Plus or minus the square root. What's b squared?
81.
Minus 4 times 1 times 31, all divided by 2 times 1. Those are my answers. I just have to simplify. So I'm going to get 9 plus or minus the square root of 81 minus 124 is negative 43. What was it again? 53? You sure? I think it's 43, isn't it? So what's that going to work out to be? If I've got that negative there, what's that going to become? I, good. And the square root of 43, is that going to simplify? I'm not going to be able to do anything with that, am I? Right, 43 is prime. So I'm going to get 9 plus or minus the square root of 43i over 2. But because I've got an imaginary number, I got to split this up right into 2 parts. I've got to have the real part, which is going to be 9/2, plus or minus the imaginary part, which is the square root of 43 over 2 times I. Right? Okay. So that's really all we're doing. We're just trying to we're just trying to find the best, let's not do this one, but we're just trying to find the best methods and then use that method to solve the equation. If I put this into standard form, I get 2x squared minus 20x plus 3 equals 0. Can I divide both sides by anything? Is there a number that goes into 2, 20, and 3?
No.
There's not. So I would say here pretty clearly that because we are stuck with a 2, this is a really easy one to choose what method you're going to use. We could maybe try to use bottoms up, but how much do you like bottoms up?
0.
0. I feel the same way. Bottoms up, it's kind of hard to do, and it may or may not even work, right? You could try it and rack your brains trying to find numbers, magic numbers, and find out there aren't any. So the moral of the story is, when you put this thing in standard form, if a is not equal to 1, what method are you probably going to use? Quadratic formula. Don't even bother with all that other stuff, right? It's going to be hard to factor. It's going to make it hard to do completing the square. So just use quadratic formula, right? So what do you think? Let's just practice a couple of these. The first assignment and the first half of your unit test is a bunch of multiple choice questions where you're just going to pick the best method. So what do we have to do with this equation first? What do I got to do first? Standard form. So I'm going to subtract x squared from both sides. I'm going to add 5 to both sides. And if I do that stuff, I end up with 5x squared minus 35x. Those cancel, those cancel, those cancel, equals 0. That looks a little weird. What about that one? We didn't talk about one like that. These are the easiest kind. If you have two terms, first of all, can I isolate x? I can't, because I've got an x squared and an x, so there's not a single x I can point to. If you've got two terms and you can't isolate x, the only one you'll ever do is this guy,
Oh, yeah, we did this all the
right? It's just factor, right? That's, if we wanted to finish that one, I would just factor out the greatest common factor. And that's it, that's all I can do. What is the greatest common factor? What divides into both of those? 5x, and I'm left with 5x times what is 5x squared? X. 5x times what is 35x? That's it, right? What are the solutions? When is that factor 0? If I said 5x equal to 0, what's the solution? X equals? No. You guys are making this too hard.
0.
0, yeah, absolutely. Right? If I set these equal to 0, by the zero product property, either 5x equals 0 or x minus 7 equals 0. Well, that happens when x is 0, right? If you ever have a monomial factor, a greatest common factor with a variable in it, the solution's always going to be 0 every time. What's the other solution going to be? 7, right? Okay, but two terms, if you can't isolate x, you're factoring. That's it, that's all you got to do, okay? And here's an example of kind of reversing that. What if I had like negative 2x times 3x plus 5? What does that equal if I distribute? Negative 6x squared. Now what if I go there? Okay, that's called distributing or multiplying, right? Factoring, if you started with this and you're factoring, all you're doing is going backwards and going to there, right? You're just undistributing. That help you put it in perspective, right? That's all you're trying to do is, what could I do to make it look like that? What could I take away from each term? Okay? What about that guy? What do I have to do first?
Oh boy, add 5x.
Got to add 5x to both sides. If I do that, I end up with negative x squared minus 8x minus 15 equals 0. Okay, that looks better, but it's still not perfect. What's wrong with that? No? The negative, yeah. We want to have, when we put this in standard form, we want a to be positive. It's negative, so how do I change the sign? Divide or multiply by -1, get the same result. What is that? It just changes the sign of everything, doesn't it? 0 stays the same, obviously. Right, so I end up with x squared plus 8x plus 15. Now I can ask myself, okay, what's the best method here?
Yeah.
Complete the square would work. Is there an even easier one? And you're kind of just working your way down the list, honestly.
Yes, and check.
Guess and check will never be the right answer. I can tell you that right now. So remember, we're always going to, and this is really the order of the things you're going to try. Can I isolate the variable? No, I can't, right? Not a single variable. Can I factor?
Yes.
I can. So that's what I should do. It's easy. What are the magic numbers? 3 and 5, right? So this one would be factoring. I could complete the square, and it's pretty easy, but that's easier, right?
So it would be wrong.
So what'll happen is you get partial credit. It gives you different amounts, it's built into the question. You get different, like you probably get 75% on the square. So you get most of it, you don't get it all. Because it's not a bad method, but it's just not the best. How about this one? Pretty obvious. What are we doing here?
Oh.
Isolate the variable. I got a single x, so there it is. Okay? How about that? It's already in standard form. That's nice. So what can I cross out? Can I isolate the variable?
No.
Can I factor?
No.
Doesn't work this time. There aren't magic numbers that multiply to 5 and add to -12, so that's off the table. Can I complete the square?
Yes.
I can, because that's even, right? A is equal to 1, and that's even, so I complete the square. Easy, right? How about that one? What do I have to do? Add 8x and subtract 28, or I could, and then I'm going to have to end up changing the sign of A. What else could I do to make A positive right away? Which side would I have to push everything to make A positive? To the right, because it's negative over here. So I could push all that stuff over there, right? If I do that, what am I going to get? I'm going to add 4x squared. I'm going to add 32x to -8x. What's that? 32 plus -8. There you go. And then 28 plus 28. Be careful, I'm adding 28 to this side. 56. And then that whole thing is equal to 0, but let's put the 0 on the right. Just flip things around and make it look better. So what else could I do to make that simpler? Divide by both sides by 4. By 4. Why not? Because 4 goes into 24 and 56, right?
Yep.
So if I divide each side by 4, 4 over 4 is 1, 24 over 4 is 6, 56 over 4 is 14. So what's it going to be? I mean, you could. Quadratic formula is going to be partial credit, but I could complete the square because A is equal to 1, and that's even. So complete the square would be the best. Okay, this guy, if we were to quickly put this in standard form, add 114 to both sides, everybody agree? I'd get 3x squared plus 39x plus 147. That's a 9. Can I divide both sides by something? 3 be the only possibility. Does 3 go into 147? How do you know it does? How do you know? No. Add up the digits. 1 plus 4 plus 7 is 12, which is divisible by 3. So it goes into that, right? So if I divide each side through by 3, I get x squared plus 13x plus 49 it was?
32.
Okay, so how about this one? Can I isolate x? No. Can I factor? Doesn't work. I can try, but it's not going to work. There are no magic numbers that multiply to 49 and add to 13. There aren't very many possibilities. You quickly find it doesn't work. Can I complete the square, or should I complete the square?
No.
No, because that's odd, right? So that gets canceled out, so what's left?
Just a check.
No, sorry. Okay? You good? Oh, here's the flow chart. I want you, before you start this is your reading. All it is looking at a flow chart for about 30 seconds. So in Moodle. Oh, darn it.
Oh, you're gonna wait. Alright.
Okay, here's the reading. Everybody look real quick. I'll let you go. Here's the reading. This flow chart. Everybody understand this? You guys know how to read a flow chart?
Yeah.
So what's it say? You start at the top. After simplifying, is there a single variable you can point to? If yes, you're done. Isolate x. That's your method. If not, then you ask yourself this. When I put the thing in standard form and I simplify that, I divide both sides by a number if I can. I make sure that a is positive. Is a greater than 1? If it is, if I'm stuck with an a that's bigger than 1, I just jump right to quadratic formula. If not, if a is equal to 1, then I ask myself, do magic numbers exist? If they do, I factor. If they don't, is b even? If it is, then I probably want to complete the square. And if it's odd, a quadratic formula, right? Now, I left out the case where there's only 2 terms. What do we always do if there's 2 terms? Factor. Unless I can isolate x, right? Okay? Go.
Oh! 50 cents up. You said you give me 50 cents. No.